This clip covers BHA analysis within Innova Engineering. So BHA analysis is actually the same calculation as the SAG analysis within the software. So when you calculate, it is BHA analysis and SAG correction. And the SAG correction result is actually a byproduct of the BHA analysis. So what I'm going to do is I'm going to go File, Open, Example Projects, and I'm going to go SAG Example Project. So as I say, the inputs for BHA analysis are almost identical to those for SAG. However, there are a few main changes. If you haven't done so already, go and watch the Innova Engineering SAG video clip available, and that will get you to this stage where we denote that all you need are the components, their ODs and IDs to denote the stiffness, the geometry of the wellbore that they're in, and the mud weight. Within the component details, you need to input the stabilizer dimensions, and the addition I would add for the BHA analysis would be your bit formation index. So the bit formation index is an indication to the software of how aggressive the bit is. So it has a range of 0 to 1. 0 to 0.3 would normally be for tricone bits, and somewhere in the region of 0.2 to 0.5, or maybe slightly more for PDC bits. What the bit formation index does is it takes the dogleg capability of that BHA in rotary, and it ratios the walk rate and build rate accordingly, depending on how aggressive that bit is. So I'm going to input a 0.3 for a very aggressive tricone bit. Next, we're going to go to the Surveys tab. So this Surveys correction section is where you set the settings for your BHA analysis. So depending on the calculation type, you can either run a BHA analysis for a single inclination dogleg severity and tool face. You can run it over an inclination range, or you can run it for surveys that you currently got in the software. So normally a BHA analysis will be done before you run the BHA. So I'll do it across an inclination range from 0 to 90 with an interval of 1. So every 1 degree inclination will give us a result. The survey offset isn't important for the BHA analysis. It is for SAG, but you have to have a survey offset input to run the BHA analysis. So if you're not fussed about the SAG result, just put in any number and the software will be able to use that to run. Also, you'd input a dogleg severity, so probably wise to put in the max anticipated for the run. And this would be a motor tool face, so you can leave that generically as 0 because it's not going to be the same tool face across the whole range. Once you've got that in place, the next thing to go to, which is different from SAG correction, is an engineering parameters. And within here, you're going to put a weight on bit. So for a 12¼ inch bit, I'm going to put 35k. And once we've input all those things, I'm going to go calculate, BHA analysis and SAG correction. Now we're going to get a warning message. It's basically telling us that the weight on bit is greater than 0. So the SAG corrections may be incorrect. And because SAG corrections are applied to surveys, for SAG, the weight on bit should be 0 because you're off bottom. But for the purposes of BHA analysis, we want to see how the BHA is going to react when we're actually drilling. So we want weight on bit included. Hit OK, it continues to run the calculation. The BHA analysis dialog opens up with graphs showing the deflected shape of the BHA and the BHA resulting slope. The results that we are interested in, we can see our inclination range that we put in from 0 to 90 degrees and the step interval of every 1 that we requested. The SAG correction we are less interested in for the purposes of BHA analysis. But what we do get is the bit side force, and the higher the side force, the higher the potential dogleg. Based upon that dogleg capability in rotary and the bit formation index number that we've input, it divides up the potential dogleg capability into build rate and walk rate. So we have a build rate and a walk rate for every inclination that we've input. Additionally, you get a critical RPM value, and the critical RPM are RPMs to avoid because they induce the natural frequency of the drill string to vibrate. So this can be viewed in real-time vibration data, view critical RPM chart, and it will denote each of the critical anticipated RPMs for your final inclination point as a red line. The results that we've created here can be exported to PDF or exported to Excel. That completes the very brief introduction to BHA analysis within Innova Engineering.